One of the most important and the first success that happened was in the context of object recognition. There was a huge data set that got created, which is called the ImageNet data set, which has lots of images and associated objects that are in the image. And if you go back to 2011, when people were solving this problem without neural solutions, without neural networks, the accuracy was about 75% with an error about 25%. This is 2011, and by 2015, in 4 years, the error went from 25% to 3.6%, and this happened basically by using neural networks. AlexNet was the first. It was an 8-layer neural network, had accuracy error of 16, then came ZFnet, VGGNet, Google had its network that created about 7% error, and then Microsoft produced a residual network. And notice the number of layers are becoming deeper and deeper and deeper. It is a deepening wall. So, as our machines, as our brains have many layers of neurons, in the very same way these neural networks have many layers in its network. And so, we have gone to 152 layers which are trained over maybe a month or something on a very, very large cluster and so on and so forth. But now it has surpassed human performance, because human performance is about 5% here. Many exciting new applications started coming. You give me a doodle, I will give you an image, or not an image. You give me a doodle, I give you a painting. You give me a style and an image, and I will combine the two to produce an image which will be the original image in a style of the first image. You give me a black and white image, I will color that for you automatically. All these and many more, and not only in vision, but in combination of vision and text, for example. So, for example, if you give me me as in the machine, a deep learning system, an image, it may produce a caption automatically. So, it produces a caption, a person riding motorcycle on a dirt road. This was unthinkable in the pre-neural network era. A group of young people playing a game of frisbee. Look how tiny the frisbee is and how the machine is able to figure out that is a game of frisbee going on. Of course, it is not always correct. For example, it believes that there are 2 dogs playing in grass and not 3, or it believes that the hockey players are fighting over a puck where they are not, they are playing their own piece, or there is a skateboarder, but there is no skateboarder here, this is a cyclist. So, it does make mistakes, but the fact that we can do even this or even this is just inconceivable, was just inconceivable a few years ago. And this has all happened due to the usage of neural networks, deep learning. Not only in vision and text, it has gone to speech recognition, where this is the automatic speech recognition accuracy from the 70s, and notice we are in the 50s and 55 and 60, 62, suddenly we have hit 95% very soon. This kind of an exponential growth has now changed the landscape in voice based assistants. Now we have Siri and Alexa and so many of these where we can build queries, and that is changing the user behavior, because in addition to keyword searches which we did all the time, we can now do voice searches, and their fraction is increasing and is projected to surpass the keyword searches as we have these assistants that we have access to. While all this success was in perceptual tasks, there were other success in decision making that was happening. For example, AlphaGo is a software by DeepMind which defeated Roger Federer of Go, Lee Sedol. And Go is a much harder game than chess, right? 1996 we defeated chess, we thought that's good, but Go was so hard that for every time I used to teach my class, I would say there are 10 years, we are 10 years away from defeating in the game of Go. And then suddenly the next year we defeated, we as in machines defeated humans. And I remember that my collaborator and I had a bet going, and I was putting my money on not winning, and I lost. But the signs were already there, because this was not an off case. They had trained one neural network architecture on a variety of Atari games. If you are old enough to remember what Atari games used to be, they found that this one architecture that they created could reach human level performance in so many of these games in one go. And then of course, there were some games that were still waiting to be solved, but their model had already started showing lots of value. So, this new model, deep learning model, has a lot of technical strengths. First of all, it is a powerful representation. It can represent any kind of function, you do not need hand coded features, and that is actually a very important point, because humans do not know how we see. So, when we have to code features about how to recognize there is a face in here and or there is a ball in here, we create some features which are sort of incomplete and not effective enough. But now with the new technology, we do not need to give those features, they are induced in a task specific way by end-to-end training. And moreover, this is one universal representation that works across modalities, like it works for text, it works for vision, it works for speech, it works for decision making. So, now when we want to have integrated systems where these technologies come together in building something bigger, it can be easily and seamlessly put together, whereas that was not possible in the olden times. Of course, it has some weaknesses. No technology is devoid of them. It is data hungry, it is compute hungry. You need so much data to train this, you need a lot of computation power. There are lots of parameters to tune, which makes the results hard to reproduce, and it operates on numbers and lots of these numbers, and it is very uninterpretable by humans. We do not know how this thing is working, we do not know how to debug it when it makes mistakes, we do not know how to understand what the model is doing. So, therefore, there are some challenges that we need